Welcome everybody from cold upstate New York. We welcome you to the hydrolysis webinar, and we will be discussing not only the instrument setup as you can see on your screen there, but also setting up samples and putting them through. So I'd like to tell you a couple things before we go. You're going to be able to type in any questions during the process here. So any questions that may come up as you look at the webinar, certainly feel free to type them in, and we will discuss those questions at the end of the actual webinar here. What else do we want to talk about? I think that's just about it, I think, at this point. So why don't you go ahead and sit back, and we'll begin right away. Let's begin our session with hydrolysis instrument setup. This is a picture of the hydrolysis instrument, and you can see the different features of the instrument indicated there, and with many different arrows. What you cannot see, as indicated on the bottom right hand side, is that the power switch and the power cord are on the actual, as you face the instrument, on the right side of the instrument, so you really can't see that in this picture. To set up the hydrolysis instrument is really quite simple. First of all, plug the power cord into an electrical power source. Next, connect the water supply hose to a fresh water source. And then finally, place the drain hose into a sink so that the solutions will flow, if you will, downhill, and ensure that the end of the hose is not underwater. The flow of solution out of the instrument is indeed gravitational, so the tubing does need to be going downhill in order to get the complete drainage. Next, attach the HCl zinc filter assembly, and you can see the picture below here, to the vent hose as shown in this picture. Position the hose and the filter to also run downhill. This will prevent any condensation from accumulating inside the filter. Pour enough water into the vessel to cover the 2 ports on the back wall of the vessel. And it's always important when you're running the HCl instrument to make sure that those 2 ports are completely covered by liquid, whether in this case it's water or during actual hydrolysis if it's the acid. It's important because those ports lead to the heaters, and the heaters must be indeed covered with liquid in order to work well. Next, plug in the power cord and turn on the power switch on the instrument's right side. Using the up and down arrows on the keypad, set an extraction time of 20 minutes. And when you have that on the setting, press Enter on the keypad. Next, again using the arrows, set the temperature of 90 degrees C and press Enter. And again, next on the keypad, set a rinse time of 10 minutes and press Enter. Close the vessel lid, and actually there will be a message on the display that will remind you to do this. Press Start on the keypad. Within 20 minutes, the water should heat to 90 degrees C. After 20 minutes, the water drain will open. Open the lid and make sure all the water has drained out of the hydrolysis vessel. You should then observe 2 rinses, with each rinse taking approximately 5 minutes to complete. And when we fill the vessel with the rinses, we actually overfill the vessel. So while it's a good idea to make sure the water is entering the vessel during that first rinse, it's also a good idea to make sure that you close the lid after that to make sure you don't get an overflow of fresh water. The hydrolysis instrument, once all these steps are complete, is now ready for use. Next, let's talk about sample preparation. Regardless of the type of sample, the most important step in the preparation is creating a homogeneous sample from which a representative aliquot may be taken. Seems pretty obvious, but it really is important. In this session, we'll discuss mixing diatomaceous earth, or as I'll refer to it, DE, with the samples in the XT4 filter bag in preparation for the hydrolysis step. And as a reminder, the XT4 is the filter bag that is also used in the XT extractor for both crude and free fat extractions. The bag has a porosity of 2 to 4 microns. Why do we use diatomaceous earth? During the hydrolysis step, the samples are placed in hydrochloric acid and the acid is heated as high as 90 degrees C. At an elevated temperatures, samples may contain low melting point fats, which can liquefy. If this occurs, the fat will tend to leach from the XT4 filter bag and be lost before the extraction. By placing DE in the bag with the sample, the fat can be absorbed by the DE and retained in the bag. Generally speaking, the higher the fat content of a sample, the more likely that sample will contain higher amounts of low melting point fats. As a result, high fat samples require more DE in the XT4 bag than do low fat samples. Another important factor when preparing the sample and DE is that no more than 1.5 grams of sample dry matter plus DE may be placed in the filter bag. If there's too much mass in the bag, that mass will restrict the acid and solvent flow through the sample during both the hydrolysis and extraction processes. The hydrolysis total fat procedure. Once the DE and sample have been weighed into the XT4 filter bags, place up to 15 bags, including we would suggest 1 to 2 blanks containing DE, into the HCl bag holder, and you can see that down below here, and clip the plastic handle into the holder. Place the HCl bag holder into the hydrolysis vessel. Pour 500 ml of 3 normal HCl into the vessel. The acid, again as we talked about before, should cover not only the bag holder, but the 2 ports on the back wall of the vessel. Using the instrument keypad, set the hydrolysis time for 60 minutes at 90 degrees C and 20 minutes of rinses. Close the lid to ensure that the water supply is on. Finally, press Start. When the hydrolysis and rinses are complete, and the time frame will be about an hour and 20 minutes, remove the bag holder from the vessel. Place 4 layers of paper towels on a flat surface and set all the samples on the paper towels. Cover the bags with 2 more layers of paper towels. Next, set the HCl blotter on the paper towels for 2 minutes. Once the 2 minutes is up, repeat with fresh paper towels for another 2 minutes. When the blotting step is complete, place the samples back into the HCl bag holder. Plug in the power cord for the RD dryer and remove the HCl filter, the black filter that you can see here. Place the HCl bag holder with the samples into the drying chamber and place the filter onto the dryer. And here this picture is taken from the top of the dryer without the filter. You can see the drying chamber with the 15 bags in the bag holder sitting in the drying chamber. Turn on the RD dryer and ensure the controller is set for 110 degrees C. With this setting, the inside of the filter bags will maintain a temperature of 100 to 105 degrees. After 3 hours, remove the filter and the bag holder. Place the samples into a desiccant pouch, allow them to cool, and reweigh them. And it's an important step at this point. In the desiccant pouch, you should place a little strip of pH paper. If there's any acid still remaining in the bags may not have dried completely, the pH paper will indicate the presence of acid. If that is the case, place the bags back into the dryer for at least another 30 minutes and repeat that process until the pH paper shows no change. When reweighed, place the samples into an XT extractor for 60 minutes at 90 degrees C. When the samples have been extracted, dry them for 30 minutes in the dryer or at 100 to 105 degrees in an oven. After 30 minutes, place the samples into a desiccant pouch, allow them to cool, and reweigh them. And this is a very important note here. When the filter bags are removed from the hydrolysis instrument, the samples will still contain some HCl. While the blotting step reduces the amount of HCl in each sample, there is still some acid left in the bags. If a lab oven is used to dry the samples after the hydrolysis, the oven will be ruined by corrosion in a very short time, certainly within a year. This is the reason the rapid dryer was developed, and we would encourage its use. For more hydrolysis-related FAQs, please refer to our website, which of course is www.ancom.com. And we thank you for watching today's webinar. Well, we hope you have enjoyed the video. I didn't introduce myself to begin. This is Brian Layton. I am the lab manager here at Ancom Technology. And if you have any questions, we've had to mute everybody's microphone. So if you want to type something in, any questions you might have, we'd be certainly happy to answer anything that we can. If as we go, let's see what direction it takes. Well, there is a very good question. What is the total time from start to finish? Well, when you place the bags into the hydrolysis instrument, you're looking at an hour and 20 minutes. You take them out and you do the blotting step. And the blotting step, again, is to try to remove as much of the acid as we possibly can. Let's call that 10 minutes for that. So now we're at an hour and a half. We're going to dry for 3 hours, so 4.5 hours. Placing the bags, then once the bags are dried, the filter bags are dried, we're going to place them into a desiccant pouch and allow them to cool. Let's call that, to make it easy, let's call that 10 minutes. So now we're at 4 hours rather than 40 minutes. And the extraction, 1 hour. So now 5, 6, it's about 6 hours total time from start to finish. Very good question. Are there any matrices that would require longer time? Not so much in the extraction phase, but it's certainly possible that the hydrolysis process could take a little bit longer, and or some stronger acid. We do suggest the use of 3-normal hydrochloric acid, but we have experimented with some up to 6-normal and have found in some cases, pretty rare cases, that the 6-normal did a better job than the 3-normal. So that's, unfortunately, we haven't seen an awful lot of samples like that, so I don't have a list that I can give you right off the top, but it is possible that the hydrolysis may take a bit longer. We found with the vast majority, and I would say 99.5% of the samples that we've tested in the XT extractor, we can extract in 1 hour. So I don't think that's a problem in that regard. Okay, no, the sample plus diatomaceous earth needs to total 1.5 grams. We found, again, as the video indicated, if you put too much sample plus diatomaceous earth in the bag, then you're going to have too much mass, and the acid will have difficulty penetrating the sample during the hydrolysis. Unfortunately, diatomaceous earth is very light, so it does create quite a mass in the bag without an awful lot of weight. So the 1.5 grams is total of the diatomaceous earth plus the sample. And you really don't want to exceed that 1.5 grams. That is dry matter, though. If you're using a liquid sample, you can place, basically you can place the 1.5 grams of diatomaceous earth in the bag, and then pipette any liquid that you may have. For example, milk is a good example of a sample that requires hydrolysis and absorbs very well into the diatomaceous earth. We have problems with residues being left in the XT15 vessel after extraction. That's interesting. I'm not sure. Any other idea as far as what the residue is? From time to time, I'll see a little bit of if you will, a little bit of blackening in the bottom of the Teflon cup after I've extracted hydrolysis samples, simply because the samples themselves have been blackened as a result of the acid in the hydrolysis, and then of course going through the drying process. I don't see that as very much, and it doesn't seem to affect the results certainly from a weight point of view, because there is very little. I'm not sure. Let's see, residue. Oh yes, okay, the blackening of the cup. Yeah, you may see just a little bit of that in the bottom of the cup, but again, it should be negligible as far as any actual weight loss is concerned. Prep samples to run the next day, leaving the samples and acid in the machine overnight. You know, it's a funny thing. We've never really experimented with running the hydrolysis on one day and then drying and extracting the next day, but I cannot imagine why that would be a problem. I think you'd be okay doing that. They're going to be sitting in the hydrolysis instrument. There will be some acid in the bags overnight. But we started with acid in the bags in the hydrolysis instrument, so I cannot imagine why that would be an issue. So if I had to answer, I would say yes, but I will not say a capital letter yes. I believe you could, yes. Any other questions? These have been very good questions. Just to let you know, we will be placing this webinar on the web. You will get a link in the email to where to find it. And actually, with all of our webinars, we do put them on the web after the day of the webinar. Once again, I do thank you all for joining us. Hopefully where you are is a little bit warmer than where we are, but I guess that's just the reality of a northern climate. It doesn't appear that there are any other questions. So again, thank you for joining us. And if you do have any questions, let me give you my email address. My email address is B as in boy, and the last name is Layton, Layton, at ancom.com. And you can see that down at the bottom of your screen right now. So certainly if you have any other questions that come up, feel free to send an email. Again, thank you very much for joining us.